First, Uber's data stack is interesting to study. So they have a 250 petabyte enterprise data lake built on Apache Hudi, all data stored in Avro or Parquet open data formats, and all data management is done through these open compute services. And they employ multiple query engines like Spark Hive for ETL, Flink for stream processing, Presto for interactive queries, and have a Hive metastore extended for access control RBAC as this extended catalog layer. Second one is Walmart. Walmart's Fortune 1, and then they have craftfully balanced a warehouse and a data lake. So they have an open data Lakehouse that delivers great data freshness on top of open data formats. Then they use Spark for scalable batch and stream processing, BigQuery for warehousing still, and then Presto and Trino for reducing some costs if for some of these interactive queries over warehousing, as I understand it. Right. And then they use all of these open source catalog sync services in Hudi to sort of sync this data to data proc catalog, a BigQuery catalog, essentially multiple catalogs. So they have a lot of optionality in bringing new engines on top. What is Onehouse doing in this problem space? Broadly, what we do is provide managed services that can replace these components in the stack, which is essentially we support ingestion, ELT, and you can prepare and transform your data incrementally. And we also centrally manage all this data that we store. And the storage is pretty much exactly how we discussed it before. It goes across different file formats, table formats, and data formats, and all of that. And we have a nice control plane which can do configuration management and make the goal is to get the data in, transform, prepare it for all the different use cases on the right. And all these components that you see in red are unbundled and swappable, like we discussed with the open source equivalents. For example, you can be ingesting using Onehouse or using open source tools, and you can still manage that table data using Onehouse's managed data management layer. So you can mix and match different components to be open or proprietary or managed. So that's a pretty interesting experience. Finally, if you're considering your next data platform, build it on an open data lakehouse. Unbundle your storage from any one engine, like engines will change all the time. Provide a modular architecture where the single source of truth on cloud storage is accessible from any engine that you may need now or in the future. And preserve your freedom to run your compute anywhere. Like I said, compute lock-in is very hard to get out of as well. So pay attention to that. And bake in efficiency from the start, and then leverage better techniques like incremental processing, efficient data management to get ahead of the curve when it comes to efficiency. It's going to be very hard to retrofit this later on.